Here are the answers to the questions on exam 2 for college physics, and this will be from the chapters that follow kinematics, like work, power, energy, momentum, rotational motion, etc. So let's look at them one by one. Here's a question. You're in a train traveling on a horizontal track and notice that a piece of luggage starts to slide directly toward the front of the train. From this observation, you can conclude that this train is. What is the train doing if the luggage is just moving to the front of the train? That means the train is clearly slowing down, because when it's slowing down, the inertia of the luggage forces it to continue moving, and that's why it's moving towards the front of the train. If the train was speeding up, then the luggage would move to the back of the train. So the answer is it's slowing down. Now, number 2, a crate is sliding down an inclined ramp at a constant speed of 0.55 meter per second. What's the vector sum of all the forces acting on this crate? The important word here is it's a constant speed. If the speed is constant, and in this case we know that it's moving down, which means the direction is constant, therefore the acceleration is 0, does not have an acceleration. If there is no acceleration, then the vector sum of all the forces cancels out, or the vector sum of all the forces is 0. And there is no such answer given amongst the choices, therefore E, none of the above choices is correct, is the answer. Number 3, a certain aircraft has a mass of 300,000 kilogram, and at a certain instant during its landing, its speed is 27 meters per second. If the braking force is constant at 445,000 Newton, what is the speed of the airplane 10 seconds later? Here, the the mass is given, the force is given, so we should be able to find the acceleration. So the acceleration in this case can be found out using acceleration is equal to force divided by mass. It comes out to be 1.48 meter per second squared. And then we can use kinematics. The initial velocity is given. We got the acceleration. Actually, it should be a negative because we know it's a slowing down because of the braking. The time is 10 seconds, therefore using this equation we would get the final velocity, 12.2 meter per second. Brings us to number 4. A 40 kilogram box is being pushed along a horizontal smooth surface. That means there is no friction, and the pushing force is 15 Newton directed at an angle of 15 degrees below the horizontal. What is the magnitude of the acceleration? So that's the direction of the force, 15 newtons, and it's at 15 degrees below the horizontal. So we have to take the horizontal component, which is going to be 15 cosine 15, which is 14.48 newtons, and that's the direction in which it's accelerating. So to find the acceleration, divide that by the mass. Gives 0.36 meter per second squared. Number 5, here you have two objects. Their mass is given. 3 kilogram and 2 kilogram. And when block B is gently released from rest, how long does it take block B to travel 80 centimeter? This is a connected system, and the acceleration of the system is given by this formula, because the force acting is the weight of B, which is its mass times G. That's the only force which is acting on the total mass of the two. And therefore, once you find the acceleration, we can use kinematics to figure out the time. The acceleration is 3.92 meter per second squared. We've got to find the time. Displacement is 0.8 meter. Initial velocity is 0. Therefore, using this equation, we can calculate the time. The first quantity, of course, becomes 0. That's why it's missing here. We get 0.639 seconds. Question 6. In order to simulate weightlessness for astronauts in training, they are flown in a vertical circle. If the passengers are to experience weightlessness, how fast should an airplane be moving at the top of the circle with a radius of 2.5 kilometers? Now, it's a vertical circle. When anything moves in a circular path, the force acting on it is the centripetal force. Now, at the top of the path, if it should be weightless, then its weight is exactly equal to the centripetal force. So mg is equal to mv squared by r. Masses get cancelled, and we can calculate the speed as 160 meters per second. In question 7, a 60 kilogram skier pushes off the top of a frictionless hill with an initial speed of 4 meters per second. How fast will she be moving after dropping 10 meters? You can do this either using kinematics or the conservation of energy, because at the top, the skier has both potential and kinetic energy, but down it only has kinetic energy. So we can either use that or we can use kinematics. The initial speed is given. You have the vertical displacement. You know the acceleration is 9.8 or negative 9.8. If you take it as negative 9.8, well, that would be better. So if you take it as negative 9.8, this is going to be negative 10. So when you plug in those numbers here, it's going to be positive anyway, because two negatives make a positive. Two negatives there. So when you take the square root, you get 14.56 meters per second. And number 8, to find the unit, you have to go with the formula, and power is work over time. But work is force times distance. I'm going to replace that with x so you don't get confused. And when you put that, change that to x. Mass is in kilogram, acceleration is meter per second squared. All right. And x is the displacement in meter per second. So when you combine, you see you get meter squared here and second cube here. So that's how you get the answer. So that's the unit of power. In number 9, a 0.4 kilogram baseball is dropped from rest from a height of 2 meters. What is the magnitude of the momentum just before it hits the ground. Alright, to find the momentum is the product of mass and velocity. That means we need to find its velocity just before it hits the ground. Initial velocity is 0. A is negative 9.8 meter per second squared. The displacement is negative 2 meter, and we could find the final velocity using kinematics. Use this equation. Once again, two negatives make a positive there, so that'll be 39.2. Got to take the square root of that. 6.26 meter per second. And then to find the momentum, multiply that velocity with the mass. So when you do that, you get 0.88 kilogram meter per second. Brings us to number 10. Here you have a collision, and you got to find out if the collision is inelastic or elastic. And there are some other choices. But you know, in any collision, momentum is always conserved. So if it's an elastic collision, the total kinetic energy before collision will be equal to the total kinetic energy after collision. So let's check that out. Let's check if the total kinetic energy before and after are equal. So let me speed that up. Total kinetic energy before collision. You know, kinetic energy is 1/2 mass times velocity squared, right? So that's what I'm doing. Finding the total kinetic energy of both, which comes out to be 6.6 joules. Now that's before collision. Let me do the same thing to find the kinetic energy after collision. Okay. And once again, you get the same quantity, the same number, which means it's a perfectly elastic collision. In number 11, a small car meshes with a large truck in a head-on collision. Which of the following statements concerning the momentum during the collision are correct? It is C, because the total momentum of the car-truck system is conserved, but not the momentum of each one separately, right? So that is the conservation of momentum. So I've just written the conservation of momentum using the symbols now. The total momentum of the car and the truck before is equal to the total momentum after. In number 12, a 20-ton truck collides with a 1,500-pound car. Okay, so one is big, the other is small. Which of the following statements is true? Always remember that during any collision, the forces applied by each one are equal and opposite, and it's independent of their masses. So the force applied by the by the truck and the car is exactly equal and opposite to the force applied by the car on the truck. In 13, that is regarding static equilibrium. You have a uniform 40 Newton board on which there are two children weighing 500 Newton and 350 Newton. The distances of the children are given, and you got to find, no, the distance of one child is given from the center. You got to find the distance of the other child. That's the diagram right there. So that's the 500 Newton child there, and then you have the 350 Newton child who should be seated further away, so X meters away. All right, in this case, the counterclockwise torque must be equal to the clockwise torque. And torque is just force multiplied by perpendicular distance. So 500 times 1.5 is equal to 350 times x, and you get x as 2.1 meter. 14th question. Inside a train, you have a ball of weight hanging by a light wire, and the wire makes an angle theta with the ceiling. Just notice that the angle is given here, and you got to find an expression for the tension. Let me draw the diagram again. That is the diagram. That's the tension. That is theta, and therefore this component is going to be T cosine theta. This is going to be T sine theta. So it's very clear that T sine theta should be equal to the weight of the ball. So T sine theta is equal to mg, which is W. So T sine theta is equal to the weight. Number 15. You have a 0.1 kilogram ball traveling horizontally at 25 meters per second, strikes a wall and rebounds at 19 meters per second. Means it's coming back. And you have to find the magnitude of the change in momentum. Momentum is a vector quantity, so you need to be careful about the direction. Momentum is the product of mass and velocity. So the initial momentum is 2.5 kilogram meter per second. The final momentum is again the mass times the velocity. Is negative now, notice, because it's moving in the opposite direction. So you get a negative there, negative 1.9. Now change in the momentum, change is always final take away initial. So it will be negative 1.9 minus 2.5, which gives negative 4.4 kilogram meter per second. But the question is asking about the magnitude of the change in momentum, which means you need not consider the sign, or you take the absolute value, which is 4.4 kilogram meter per second. 16. A meter stick balances at the 50 centimeter mark. That means its mass is, or its weight rather, is acting right through its center at the 50 centimeter mark. And then you have a mass of 50 gram placed at the 90 centimeter mark. And now the stick balances at the 61.3 centimeter mark. So that is the diagram there. So that is the 61.3 centimeter, 90 and 50, and you have to find the mass of the meter stick. So that's 50 gram. It's very clear that the clockwise torque of this 50 gram is equal to the counterclockwise torque of the mass of the meter stick. So remember, the mass of the meter stick is acting right through 50. So which means 50 times this distance should be equal to m times this distance. Right, so m times that is equal to 50 times the other distance. When you do the calculations, you get the mass of the meter stick as 127 gram. 17. A lightweight object and a very heavy object are sliding with equal speeds along a level frictionless surface. They both slide up the same frictionless hill with no air resistance, which object rises to a greater height. Okay. Now in this scenario, the kinetic energy of the objects become equal to their potential energy. So when you think about the equation for kinetic energy, which is 1/2 mv squared, that should become equal to mgh. The masses get cancelled, which means that the height is v squared by 2g, or in other words, let me move that. In other words, the height only depends on the initial velocities. It does not depend on the masses. And since the speeds are equal, they both slide to exactly the same height. Now 18, as you're leaving a building, the door opens outward. The hinges on the door are on your right. What is the direction of the angular velocity of the door? The direction of angular velocity is given by the right hand palm rule, where, the direction of the closed fingers give the direction of rotation. The direction of the angular speed is given by the thumb. Okay? Now in this case, you got to hold that right hand with the thumb down, because, let me try to draw a rough diagram. If that's the door, here are the hinges, and the door is opening outward, which means it's rotating that way. So you'll have to hold your fingers, closed fingers, in that direction, which means the thumb is going to be pointing down there. Therefore, the answer is down. At a certain instant, a compact disc is rotating at 210 RPM. That's rotations per minute. What is the angular speed? First of all, you have to change the rotations per minute into rotations per second by dividing by 60. And then that gives 2.5. And then angular speed is 2 pi times f, which gives that was 3.5, I'm sorry, so changed it. So that's 22 radians per second. And the last question here, through how many degrees does a 33 RPM turntable rotate in 0.32 seconds? Once again, the frequency is in RPM, change it into rotations per second. .55 rotations per second, and then find the angular speed. Once you get the angular speed, you can find the angle, because angular speed is theta by t. Rearrange, you get theta. Theta is 3.46 times 0.32, which gives 1.1 radian, but the answers are in degrees, so you need to know that 1 radian is 180 by pi degrees. So multiply 1.1 with 180, divide by pi, and there you go, you have the answer, 63 degrees. Dear students, I've tried to do this as fast as possible because I know that you can pause the video, but I wanted it to be a shorter video. Alright, so here it is. I hope it's useful for you. Go ahead and like the video and share it, please. Thank you again, and I hope you do good on the exam.